Welcome back to Maths with Mrs. J. We've been working a lot with logarithms, simplifying them, using our log laws. Now we're ready to actually solve some equations, either that involve logs or that we can bring logs in to help us. Have a look at the first one we've got here. Remember, if nothing's written, it's base 10. The easiest way to solve this is to go back to index notation. So if log of 2x is 3, then that's telling me that 2x is 10 cubed. All right, 10 to the 3 is 2x. So 2x is obviously 1,000 and x is obviously going to be half that, which is 500. We should check that it works. Yes, 2 times 500 is 1,000. Log of 1,000 is 3, so we're all good there. Second one, what we're going to want to do here is get the left-hand side as just one log. Now, we know that if we are adding logs, we need to multiply the powers. I'm going to do double brackets here just to remind ourselves of this. All right, so just expanding here, I'm going to get x squared minus 2x plus 1x, so minus x minus 2, and that equals 1. All right, now we can go and do a similar step to what we did in the previous one, and we'll say, well, 10 to the 1 is this. So x squared minus x minus 2 is 10 to the 1, which is 10. We're going to bring everything over this side, and what we end up with is a quadratic equation to solve. This is a fairly easy one. We've just got a 1 in front of our x squared term. So we want x minus 4, x plus 3 is 0. So you get x is 4 or negative 3. Now, we do need to be a little bit careful here. X equals 4. Does that sub in correctly? If x is 4, you get log of 5 plus log of 2. That's log of 10. That is 1. That's okay. So that one's okay. If you sub in negative 3, you're going to get log of something negative, which you can't get. So that one is not feasible. So we say x is just 4 is our only solution for that one. Always be careful. Just because you get a quadratic that yields 2 solutions does not necessarily mean that both those solutions will be feasible. You need to check on that. Let's do an example now where we start off with an index equation and we're actually going to use logs to help us now. In the past, we wouldn't have been able to solve this. We would have been able to get some idea because we know that 4 to the 1 is 4 and 4 squared is 16. So we'd be expecting a number close-ish to 1, but between 1 and 2, wouldn't we? In order to get this exactly, we're going to write the log. It's log of 5 to base 4, isn't it? That's the exact answer to this question. However, if I want to have a rough idea of what that's going to be, I can use my calculator and our change of base rule. If we change base to base 10, we're going to get log of 5 on log of 4. If you do that on your calculator and round off to 2 decimal places, you get 1.16, which is what we thought it would be approximately, because 5 is only a little bit bigger than 4, which is 4 to the 1. Just do one more. So say we had e to the x equals pi. This one's a cool one because not only do you have e, which is a super cool transcendental number, you have pi, which is another super cool transcendental number. So they're irrational numbers that are not in the form of a surd. All right, well, let's change to log notation. So x is obviously log of pi to base e. Now, you can actually go straight to your calculator for that because you've got a natural log button. And if you do that, you're going to get an approximate answer of 1.14. If you forgot that you've got the capability of doing that, you could say that's log to base 10 of pi over log to base 10 of e. But it's not necessary to do that because you can do logs to base e directly on your calculator. E, by the way, is about 2.71. Pi is about 3.14. So it makes sense that we have a number a little bit bigger than 1 as our answer. We should always be thinking, is our answer at least vaguely sensible?